Okay, thank you for being here. And for those of you who don't know me, I'm from Shenghu. I'm the Richard G. Engelsman Dean of Arts and Sciences. And I'm also a professor in the Department of Earth, Environmental and Planetary Sciences, in case you don't remember. It is an honor to welcome you to the installation of William B. McKinnon as the Clark Way Harrison Distinguished Professor in Arts and Sciences. It is wonderful and no surprise to see so many colleagues and members of our WashU community here today to honor our legendary colleague and friend, Bill McKinnon. We are especially delighted to have several members of Bill's family with us today, both here and online. They are Bill's partner, Tina Richardson, who I just met, Bill's sons, Liam and Evan McKinnon, and Bill's daughter-in-law, Willow McKinnon. Several family members are joining us via live stream, including Bill's daughter, Brianna Date, Bill's sister, Mary Saunier, Bill's brothers, Fraser and Stuart McKinnon. With Bill's guests here in the room, please stand to be recognized. Thank you all for being here for this special celebration, and thank you to everyone for joining us via live stream as well. As Dean, I often talk about a rock star faculty, and Bill McKinnon is a true rock star of research, teaching, and discovery. Thanks to his decades of work in Earth and planetary sciences, we understand far more about our solar system than many ever imagined possible. What makes Bill so exceptional beyond the outstanding science is that he doesn't seek recognition. In fact, he did not ask for this endowed professorship we're celebrating today. It was David Feig, the department chair, and I who felt so strongly about recognizing his many contributions that we surprised him by taking him out for casual lunch last year. Something that I know Bill would have never orchestrated for himself. So Bill, your humility is part of what makes you so admired by so many people. I hope you will indulge me for a few minutes as we reflect on your many accomplishments. But how do we talk about Bill's impact in just a few minutes? That's a big challenge, but I'm going to try to sum it up in one sentence. His work has taken us to the ends of our solar system, around the moons of outer planets, and beyond the boundaries of our earthly imaginations. How about that? He has challenged us to explore paradigm shifts and the forces that shape the objects in a world much bigger than ourselves. And for more than 4 decades, Bill has been a prime example of what makes WashU a premier institution for research and discovery. Elected to the National Academy of Sciences in 2023, Bill is a professor of Earth, Environmental and Planetary Sciences and currently serves as interim director of the McDonald Center for the Space Sciences. His pioneering research has transformed our understanding of the outer solar system, especially Pluto and its largest moon. He has played leading roles in major NASA missions, including as a key scientist on the New Horizons mission, the first to reach Pluto, and as a science team member for the Europa Clipper mission, which will soon explore Jupiter's icy ocean-bearing moon in the search for signs of life. Bill's accolades are numerous. Most recently, he received the 2023 Kuiper Prize from the Division for Planetary Sciences of the American Astronomical Society, and he has held leadership roles in organizations such as the American Geophysical Union and the National Academy's Committee on Astrobiology and Planetary Sciences. Bill's passion for science is contagious. You see it in his teaching, in his media appearances, and in every conversation about his work. It truly exemplifies the spirit of arts and sciences and our shared excitement for discovery and research. So in just a few minutes, you're going to hear a lot more about Bill and his career from David Fike. And of course, we will not be here today for this wonderful celebration without the generous donors that gave us the funds to endow this professorship. Maxine Harrison, whose estate gift established the Clark W. Harrison Distinguished Professorship in 1991. It was initially an endowed visiting professorship in honor of her father, and after I came here, I recognized that the visiting professorship was not used wisely, so I decided to make it a permanent endowed professorship, and that's why Bill has this permanent endowed professorship now. So his father, Maxine's father, graduated from WashU in the late 1800s and went on to become a successful business executive in the iron and rubber industries. Maxine was born in January 1902. She graduated from Smith College in 1924 and went on to work as an international correspondent for newspapers in Mexico and the Philippines, covering presidential visits from Presidents Dwight D. Eisenhower and John F. Kennedy. She passed away in October 1991 at the age of 89. So in some way, I just thought that this is a perfect match. The donor was so incredibly humble that we couldn't find much information about her or her family. And we got Bill, who's so incredibly accomplished and yet so humble too. So it's a great match in that regard as well. We are grateful to supporters like Maxine and her family, whose generous gifts help us build our legacy of world-class faculty in arts and sciences, including Bill that we're celebrating today. With that, now I'm going to turn it over to David Fike. David, please come up to the podium and tell us more about Bill and his career. And as you all know, David is the chair of the Department of Earth, Environmental, and Planetary Sciences.
Good afternoon. It's a real pleasure to be here. As Dean Hu mentioned, I'm the chair of the Earth, Environmental, and Planetary Sciences Department, where I have the privilege of working very closely with Bill McKinnon, and I have the pleasure of introducing him here today. Bill originally hails from Montreal and earned a bachelor's degree from MIT in 1976 in Earth and Planetary Sciences, staying on the East Coast, and ventured across to Caltech, a not uncommon transition, to get his master's and his PhD in 1981. He was working primarily with Jay Malosh, looking at impact cratering, with a perhaps foolish focus at the time of terrestrial type planets, of Moon, Mars, Mercury. He learned better later on. Upon graduating, he headed to the University of Arizona, a real powerhouse in planetary scientists, first as a research associate and then as a senior research associate in 1982, where he was working on the Voyager missions. And at this point, he found his own research interests drifting further out to the outer solar system. At that point, we swooped in and stole him. Bill joined the faculty here at WashU in 1982 as an assistant professor in the Department of Earth and Planetary Sciences, as we were known at the time, and also as a faculty fellow of the McDonald Center for the Space Sciences. Bill was promoted to associate professor in 1988 and to full professor in 1997. And as Dean Hu mentioned, he is currently acting as the director for the McDonald Center for the Space Sciences since this past July, where he's seeking to advance space sciences not only across campus, but in the wider world. In addition to his time here at WashU, Bill has had visiting appointments at Southwest Research Institute and back at MIT and JPL. Bill is a world-renowned expert in planetary science and has been a critical player in many NASA missions, with a particular focus, again, in the outer planets. In addition to the missions that Dean Hu mentioned earlier to explore the Kuiper Belt, Bill is a science team member for the Radar and Icy Moons Explorer instrument on ESA's JUICE mission, co-investigator for both the Radar for Europa Assessment and Sounding, Ocean to Near Surface, REASON instrument, and the mass spectrometer for planetary exploration Europa, or mass spec instrument for NASA's Europa Clipper mission. He was the co-chair for the Habitability Assessment Board of the Europa Clipper mission, as well as a science team collaborator for NASA's Juno mission to Jupiter. Over his career, Bill has authored over 200 publications, book chapters, edited volumes. As an aside, as an eager young undergraduate in the mid-90s, I remember reading your 1988 paper in my solar system astronomy class about Pluto. He teaches courses on the solar system and all aspects of planetary science, where he's one of our most dedicated and engaging faculty. He has helped shape future leaders in planetary science over the decades through his undergraduate and graduate advising. In addition to the honors that Dean Hu mentioned, he has also been named Fellow of the American Association for the Advancement of Science, AAAS, the Geological Society of America, and the American Geophysical Union. He's received the G.K. Gilbert Award and the Sir Arthur Clarke Award, in addition to being inducted, as Dean Hu said, to the National Academy of Sciences. Quite an impressive career, and more still to come. For as Bill has noted, exploring the outer solar system takes a long time, and so his career arc has been one of delayed gratification. Bill, we are delighted and gratified to be able to have you installed today, and I'll give you Bill. Thank you so much. Thank you. How's it doing?
All right, so I have this beautiful medallion here. You can all see it, right? The front says, Clark Way Harrison, Distinguished Professor, Washington University in St. Louis, 1853, Arts and Sciences. On the back, it says William Bill McKinnon, September 30th, 2025. So I'm now going to put it on Bill, and Bill, you're going to have to keep it on forever. Okay. Yes. Okay. Podium's yours.
Okay, thank you, gentlemen. I feel like I've come to Oz and met the wizard. Wow. Well, I don't know what to say after that. It's really too much, really too much. It's wonderful to see all of my family and friends, and it's hard to say anything else. I'm humbled, and I am deeply gratified. So it's been a great arc, life arc, and wow. I was asked to give a few remarks on my own choosing, so I thought I would show a few slides, call it sort of To Pluto and Beyond. It's not really about Pluto. It's like, how do you start, in a hospital in Montreal and end up at the edge of the solar system? It's one thing I can say, different people have different interests. I have always been interested in the planets ever since I was very, very small. And so these are actually two of my favorite books. They still are, from the mid-1950s. And they're extremely well written. And you can even see that they're even sort of modern in their understanding of the moon. This is, pre-Apollo, the impact cratering as opposed to exploding volcanoes and so forth, and really well written. And I always wanted to see all these places because you couldn't. I didn't know what the surface of Mars looked like or what any of the moons of any place looked like. And this to me was just the most fascinating thing. That and dinosaurs, and I chose planets. And I'll just say this man, Roy L. Gallant, he wrote an enormous number of books over his career, and I found out that he lived to be 101 and only died last month. So it's just really, really impressive. Of course, the 50s are one thing, but then of course, you start to get older and, then it's the 60s, and what an incredible time to be alive. I mean, the music was great, but also the space business, we were going to the moon. I remember in elementary school, John Glenn's flight, we all marched into the auditorium to watch the liftoff and all this sort of business. People often ask me, didn't you want to be an astronaut? And I said, well, no, my eyesight was never good enough. I was too tall. And frankly, I couldn't fill Neil Armstrong's shoes. I mean, I tried. They're really big. Moon boots are actually really big. I never realized that for the obvious reason. They have to be protecting. But, ultimately, and I didn't know you could pursue this as a research career. But I knew I wanted science. So that's why I left Louisiana and went to MIT, because I knew it was like a temple of science and there'd be something for me. Physics seemed like a great idea, but slowly and surely I was seduced to the dark side of geology and rocks and things of that sort, because that's the path where the planets lie, because planets are made of rocks. And in particular, I'd like to give a shout out to some people along the way that were very influential for me. These gentlemen, John Lewis and Erwin Shapiro, taught a wonderful course that I took 50 years ago, fall of 1975. Okay, it's a year-long course, Physics and Chemistry of the Planets. Bruce, I know, remembers this very well, Bruce Begley. So it was just a marvelous introduction, and that's kind of the springboard, again, to learning more and more about the planets. And I was introduced to a lot of really advanced ideas in this undergraduate course. And I just have to say, again, for any of the students in the audience or people who have students as children, the time you have as an undergraduate or a graduate student is just so precious and wonderful. You should just make the maximum out of it, certainly in terms of friendship. The people I met at MIT was so important to the ability to do anything in the field. I think even more important, more valuable than graduate school in a way. I still have dear friends from those years. We get together and we have a more marvelous time. This is actually the avatar version of roommates of mine over time. And we met for Steve's 70th birthday last year. And it's interesting, all three of them, and everybody from my high school that I remember or still know about they're all retired. Somehow I haven't got the memo. So, but it's a marvelous thing, these enduring friendships, and that also ports over into, I think, research collaborations, at least for me. Now, of course, this is just last year. Let's go back in time. My first real job as a planetary scientist was on the Viking mission, Mars, the first American Mars lander. So I was an intern in the summer after I graduated. And the interesting thing about this activity is that it did not turn me into a Martian. Okay, and I'll tell you a little bit why a little bit later. But that was my first taste of California, because I'd never been west of the Mississippi. I guess technically the West Bank of the Mississippi in New Orleans, where my friend from high school, Jamie, who's here, that's as far as I ever had gotten. So it was a marvelous thing just to see this mythical land. And I stayed out there. I went to Caltech, like David said. And it's a very interesting department, very different from the people I had met at MIT, really. The most famous planetary geologist in the department at that time was a guy named Bruce Murray. He helped found the Planetary Society. But at the very moment I went there, he went to run JPL. And as far as I could tell, he never set foot on the Caltech campus again. So what I did, though, because I had the option of working with different people, I could study atmospheres, I could study radar astronomy, I could do this, do that, but the only way to really study anything about solid surfaces was to work with the young guy in the department, and his name was Jay Malash. This is not a young picture of him. Jay's unfortunately no longer with us. He was a great scientist and he loved explosions, especially things made by impacts. And so that's really where I got started studying the physics of impact cratering and especially the formation of the very largest structures, which we call the multi-ring basins. And you see a beautiful example, one and the youngest one on the surface of the moon, Oriental. Now, that got a certain amount of play, but even by the late 70s when I was doing the work, it's like the moon has already been there, done that. The Apollo program is over. Okay, so, okay. But something was happening off in the hinterlands that I really wasn't too aware of. And it's a pivot point for basically my life. And as David mentioned, the launch of the Voyager missions occurred in 1977 on a fast track to encounter both Jupiter and Saturn. And they got there in 1979. And this is the middle of 1979. My PhD advisor decided, I'm leaving. And he went off to another institution, ultimately to have a great career at the University of Arizona and then Purdue. And then I decided, well, I guess I have to write up what I got and get out of here. But fortune favors the prepared. And, what we saw of these moons, this was the first mission that had real good imaging and other data for the moons of Jupiter. And so when we saw that they did in fact have craters, because people had predicted there would be none because they would all flatten out by glacial flow, in fact, we found fantastic versions of these multi-ring basins that are multi. And basically the work that I had been doing was easily transformed. In fact, from my point of view, it made my thesis actually interesting. So that was the pivot, okay, that we now had a new arena, whole new kind of data where we could actually understand the geology of worlds where the material is not necessarily granite or basalt or peridotite, sorry, Phil, but ice. Water ice especially, but also other ices, ultimately, nitrogen ice, methane ice. So that became an arena, and I'm not going to go through all these details, but over the years then, I've been looking at different moons because the Voyagers went to Jupiter and they went to Saturn. And so we had all of these different places with different kind of modalities and expressions, and I could work with different students and postdocs. And once I did work with people, especially, I would stay working with them. And it's just really a marvelous experience. In fact, that's the most fun I could practically have, Frank. I want to highlight just one person. The upper right there is my first PhD student, a fellow named Paul Schenk, who will be visiting us in a few weeks. He, remarkably perceptive planetary geologist. And he was the one who recognized that this pattern of sort of arrows and lines on the surface of Europa actually indicated that the surface was mobile, that there were sort of plates or platelets moving. And this was very controversial at the time. This is part of the line of evidence that ultimately built the case that there's a subsurface ocean, and which is why NASA is returning to that with the fabulous Europa Clipper mission. And that has continued, and that's a thread, and that's great. But something else happened, okay? Right before I came to WashU was the second pivot point. And that is what Voyager was not going to study. Voyager was not going to go to Pluto, this remote, at the time, planet, And I just basically got a bee in my bonnet, and I wanted, it's a side gig. I said, there was this crazy idea from the 1930s that Pluto was an escaped satellite of Neptune. And I always thought this was a bit preposterous, but I said, but nobody had ever written why or why not. And so I decided I would write a paper about it and sort of showing from principles of physics that this wouldn't be the case. But in doing so, instead of having, as it was proposed in the 1930s, Pluto and Triton together were satellites of Neptune, and they had an interaction. Pluto was kicked out to orbit the sun, and then Triton was sent backwards. I said, well, what if wouldn't it be more natural if they were outside, just orbiting the sun, and Triton was captured by Neptune, and Pluto was just itself? And the capture of Triton, though, oh, wait a second, that's going to involve orbital circularization and tremendous amount of tidal energy, and the thing will melt. And so all of this got, this was kind of, it was very entertaining anyway, but it also, for some reason, got a lot of play. It was written up on the science page of the New York Times at the time, and it's like, they're paying attention to this. This isn't my main line. It's like I'm supposed to be an impact crater guy. So that kind of, I locked onto that and kept pursuing it because, the implications are, oops, let's see, there we go. The implications are that if this is true, then Pluto, it's too mysterious if it's just the two of them out there. There's got to be a lot more. And in fact, it was only a few years later that we actually discovered the first of what we now call the Kuiper Belt objects that is beyond Pluto and its moon. And so this has gone on, and now there are thousands of them. And it just became a kind of passion for at least the younger people in the planetary field. And the Voyagers, of course, one of the Voyagers, Voyager 2, was actually then, it was okay after a while. It was so successful that after Saturn, it actually was sent on to Uranus and then to Neptune. So we were actually going to see Triton and see if, in fact, the surface had melted. And in fact, we didn't know anything about Triton. We didn't know how big it was. We didn't know how dense it was. But it really was fantastic data that we got in 1979. So that was and that's again still a while back, but it's again, it's a different sort of thread. You just you never know. You just never know what's going to come up as what's interesting. Of course, somebody is left out of this story so far. It's the P word, Pluto. And so after that Neptune encounter and looking at Triton, people actually began to think about Pluto more seriously, at least the younger folks at the time. And so we called ourselves the Pluto Underground, and we were kind of bugging, no, it's true, we were bugging NASA to send a mission to Pluto, okay? It was still a planet, okay, at the time. And there's a long story about, different proposals that came and went. But ultimately, NASA did actually decide that this was worth doing. And in this case, it's not about pivoting, it's about perseverance. So you just kind of keep at it. And of course, a key thing was that with more bodies discovered out beyond Neptune that we now call the Kuiper Belt, then it meant that in fact this was a third zone of the solar system. It was it's a rich arena that we knew very, very little about. So it became logical to at least spend some resources and time trying to explore this world. But this took a decade, more than a decade of agitation, okay? But we eventually won a competition. Actually, we won it more than once. So here's a scan from the WashU record. We used to print this on this thing called paper. And so the announcement here is that we're going to go to Pluto, that the mission was approved in October of 2001. And this is from 2002. So it took 12 years to get the mission going, but of course it's a long way to Pluto. Delayed gratification is a real thing in this business. So from 2001, it was another 14 years until the Pluto encounter. So that's 26 years. That's like a career arc. I can't tell you how many times Doug Weens would say, "So when are you getting to Pluto?" Anyway, and all the details, it's not a shameless plug because I didn't write this book, but the peregrinations of how this all occurred are all in this fabulous book that the principal investigator for New Horizons, Alan Stern, wrote with the noted author, David Grinspoon. So we got there in July of 2015. We just had a 10-year anniversary meeting to kind of go over all the old data and think about new things. And it was really a marvelous, an incredible experience because the New Horizons spacecraft that we designed had much better instruments than the Voyager ever did, much more modern ones. So we had much better data. And in a sense, also that the encounter was designed in a much better way. So there was all sorts of fabulous stuff. And I'm not going to go into all the crazy details, but it's like the excitement from the front page of the Times tells the story there. But even as interesting geologically as it is, sort of like the whole idea is that we look at different worlds and we see how forces and chemistry, express themselves under different conditions. Even more than this was after Pluto, we, using telescopes, had spotted very smaller Kuiper Belt objects, and we had a subsequent encounter several years later with a small Kuiper Belt object which we now call Arakoth. This thing is only about 35 kilometers end to end, and it's basically two flattened, sort of like potato-like things just gently touching one another. This is like a picture of an actual planetesimal. So we finally found out in deep space where the collision rates are so low, we found like a fossil from the very beginning of the solar system, because like the asteroid belt has been collisionally re-scrambled again and again and again. This object hasn't, and it really paid to an argument in the field about how planets actually form. Because in the late 20th century, the idea was little pieces stick together and they get bigger and bigger, and there's an endless hierarchy of collisions and then ever more violent. But an alternate theory involves a lot of small particles and the gas that used to circle the sun, what we call the solar nebula, and there's a collective activity. It's kind of like the riders in the Tour de France crashing into one another, and you get a planetesimal of some substantial size formed all at once. And then those guys can then put themselves together. But these sort of collapsing clouds of what astrophysicists and planetary scientists call pebbles, which are very different from what real geologists call pebbles, is what we think. And this is the proof. This object is the proof. And in some ways, it's much more important. And so, you know, we can even put together an entire story from a review article about how bodies like Pluto form. And I'm not going to go through the details because of the time, but you know, we can start with these individual planetesimal clouds. Maybe I'll just go back for a second. Because of angular momentum conservation, you don't necessarily just get a planetesimal, you might get two orbiting one another. And if there's a dissipative process, then they can spiral in what we dynamicists call hardening, and they can just touch and stick. And in Pluto's case, it of course grew ultimately from, you know, these larger planetesimals that form, but, you know, we put a whole story together, and the ultimate, at the end, though it is a collision that ultimately forms Pluto's giant moon. And in fact, there's a fantastic correspondence on a kind of miniature bonsai scale about the Pluto-Charon system and the Earth-Moon system, both in their mass ratio and their formation scenario, and even the outward growth of the orbit of our moon due to tidal forces and Pluto's moon as well. Pluto, by the way, has 5 moons. It's a very busy place. It is really a planet. Maybe we should vote on it in here. I don't know. Anyway, so the big summary is that, you know, there's an almost infinite variety of experience in the icy worlds. It's not just the icy satellites of the giant planets, but it's what we now know there are thousands of Kuiper Belt objects, or sometimes called trans-Neptunian objects. And so some of these things we've seen close up, some of them have atmospheres, some of them are active now, some of them are dead. It all depends. And so it's just a marvelous arena to work, and it's a very big field now, icy worlds, very big field. When I started it, well, I told you, there was nobody doing it, nobody. So it's marvelous to see this whole thing happen. I do want to give a shout out also all the way back. You know, none of this would have been possible without the, you know, love and support of family and friends, but especially family. My father, you see here, who only died a few years ago, he was a surgeon, and he was not somebody who pressured, you know, his sons to go into medicine. So I always liked it that even if they didn't understand what I was doing, at least they appreciated that I was doing what I wanted and that it was okay. So this is a bunch of brothers and sisters and in-laws and kids when they were young and so forth. I will say that my next youngest brother, who's kind of in the middle up here, he actually did become an MD and also got a PhD in chemistry along the way. And when he actually dug up the obituary for Clark Way Harrison, the namesake on this medal, and told me all about it, sent me the New York Times obituary, and said, given since he ran a rubber company, that my installation really was a vulcanization. So that was, okay. Now, the title of the talk was to Pluto and beyond. And you might ask, where's the beyond in all of this? And of course, there is all sorts of things to do in the solar system. And as I say, we've been discovering so many more bodies. This is a map that shows you, if you can see it well enough, the little circle in here is not the orbit of the Earth like you might think. It's actually the orbit of Neptune, and that's kind of where Pluto lives. So there are all of these extremely distant worlds on very elongated orbit. We have no real idea where the solar system ends. And of course, there are thousands of planets around other stars, which are much harder to study. So there is that beyond. But for me, given time and temperament, what I intend to do in my golden years is to go beyond and back. And I'm circling back to the moons of Jupiter, where all of this started for me back 50 years ago. So I'm involved with, like the Dean who said, with these two missions, the Jupiter Icy Moons Explorer, which is going to orbit Ganymede, and the Europa Clipper mission, which is not going to orbit Europa because the radiation environment is so fierce, but will pass by it dozens and dozens of times. And we have multiple fantastic instruments. Both of these machines are in flight, and both of them will get there in either 2030 or 2031. And again, just last week, we had a seminar speaker who came into my office and said, "How can you wait for so long?" I said, "Madam, it's only 4 years or 5 years. I waited 9.5 years to get to Pluto." With that, I'll just close with just profound thanks to all of you for coming, but also looking back across time to all of my teachers and mentors. It's fantastic to think about. All the students and postdocs that I have worked with, all of my colleagues and collaborators, most of which, like when I mentioned Paul Schenk, we're writing papers right now together. So that's, it's just marvelous. And of course, all my family and dear friends. Thank you very much.
Well, this is such a fabulous lecture, and today is his day, so you cannot ask him questions. I really appreciate that these presentations and installations they're some of truly my favorite. You have to force yourself to capture the essence of your career. In this case, a brilliant career of 40 years. And all the Nature and Science articles they cited on the slides. Bill, I know that you're going to be doing all sorts of fascinating research and teaching generations of students for the next 40 years. And I think David and I are going to just take a class from you when we retire. But how about that? All right, this concludes the formal portion of today's ceremony. So please join us back there for the reception. Thank you all for attending the ceremony. And congratulations again to Bill and the families.